So this is going to be part 3 of P3. Okay, today we're doing factoring, difference of two squares. I know we talked about this last year, of all of this, so do you remember what the difference of two squares is? Difference of two squares, where you have u squared minus v squared. What does that factor out to? This is where you had to memorize. If I had the difference, what?
U plus
Yeah.
V, U minus.
Exactly. U plus v, u minus v. So when you are factoring, okay, you have u squared minus v squared, you get u plus v, u minus v. So if I have 9x squared minus 4, that's a difference of two squares. It would be the same as 3x minus 2, 3x plus 2, difference of two squares. Okay? No, yesterday we went backwards. We did special products. So yes, it's written down, but this is just seeing it in the flipped version. Like if they give you this version, you have to be able to go that way. It's okay, trust me. You writing this down twice won't hurt you.
My hands hurt.
Then you have perfect square trinomial. Perfect square trinomial. Maybe writing it down today, Parker, would be good then. U squared plus 2uv plus v squared, perfect square trinomial. So, or perfect square trinomial. And this factors, or this breaks down into u plus v squared. Okay, so if you have x squared plus 6x plus 9, it's going to break down into x plus 3 squared. You take the square root of that and the square root of that, and that's how you get your answer for the perfect square trinomial. When you are adding, when you are subtracting, it would look opposite. U squared minus 2uv plus v squared, which means take the square root of that, take the square root of that, put a minus sign in between them, and you have it factored, or you have it condensed. So if you do that with these numbers again, x squared minus 6x plus 9, square root of that, stick a minus sign in between it, and you have your perfect square trinomial.
What page is this on?
27. The other part, the last one, is the sum or difference of two cubes, which we also looked at yesterday, but we're going to reverse it today. Sum or difference of two cubes. Okay. This is the one that you have to memorize also, because this one is where it gets really tricky if it's not memorized. So if you have u cubed plus v cubed, okay, it's going to come out to equal u plus v times u squared minus uv plus v squared. So when you have a plus, this sign here is a minus, okay? With numbers, x cubed plus 8, you have to first recognize that 8 is a perfect cube. So there's where some of our problem comes in. We got to recognize what perfect cubes are. So then I have x plus 2, because that's the cube root of 8. Then I have x squared plus, I'm sorry, this should, yeah, no, that is a plus. X squared minus, because that's a plus. X squared minus, and then I take the cube of this, multiply it by the cube root of that, so 2x. And then I'm taking the cube root of 8 and I'm squaring it, so plus 4. And that is the pattern for the sum or difference of two cubes, for the sum of two cubes. The pattern for the difference of two cubes would be if I have u cubed minus v cubed, it's going to be u, okay? And then it's going to be minus here instead of the plus because I have a minus. And then it's going to be u squared plus uv, okay? And then it's going to be plus v squared. So this whole inside has pluses, this one is a minus. If you do that with 27x cubed minus 1, you have to realize that 27 has a perfect cube, x has a perfect cube, 1 has a perfect cube. The perfect cube of 27 is 3, so you're going to get 3x right there minus 1, because the cube of 1 is 1. Then you come over here and you square the cube root of this. So 3x squared is 9x squared. You times 3x by 1 so that you get 3x in the middle, and then you cube negative 1, or you cube 1, giving you that. That is how you do the difference of two cubes. They are patterns you have to memorize. Get a tattoo of it? Oh.
Will you make us have to wear it?
So then, let's talk about removing some common factors. Factoring. Okay, tonight you're going to do some factoring. Removing common factors. Let's say you have 3 minus 12x squared. What can I remove from all of that? What can I remove from all of that? Let's factor it. What can you remove from 3 minus 12x squared? 3. So if I remove a 3, I am left with what?
So writing down difference of cubes.
Yeah.
Okay.
I just started somewhere different.
We're slow. You have to go slow.
So if I factor that, I get 3 times 1 minus 4x squared.
Stupid kids.
Keep going. I'll give you a minute.
I just finished the word cubes, so I'm gonna be like.
Okay, well, we won't wait fully on Parker, but we'll wait on.
I just finished the first
That's fine, Alex. You
two
keep going.
letters of the summation.
Okay.
What?
I don't know what you're doing, but we gotta go on. Okay. So we factor that. Let's talk about how we could factor this. How do you factor 100 minus 4y squared? What can you do? What?
25.
Can 25 go into 4?
No, I'll do that later.
You want more?
Yes, but whatever I take out has to come out of both of them.
4. Then you should get 25.
Okay, I could take 4.
Or you
I want to know what happens. Think with me here first. What happens if I just take out a negative 1? Okay, then I have 4y squared minus 100. What do you know about the number 100 and about 4y squared? They're perfect squares. So they are a difference of squares. So if I take out that negative and rearrange it, I have a difference of squares, which means what would go here and what would go there? Like, how would that pattern break down?
like a 2 and a 50.
Not a 2 and a 50. 50 times 50 is not 100. What times what is 100? 10. Okay? So like a 2 and a 10. So I'm going to put a 2y here plus 10, and then I'm going to put a 2y here minus 10. Now, can these be factored further? Yeah. You can what? I can take a 2 out of this, right? Okay, so that it's like 2y plus 5, right? And then I can take a 2 out of here, so that it's 2y minus 5. Okay, that's like a way that I can factor. You could technically multiply all of these together to make negative 4 on the outside, y plus 5, y minus 5. So will this stuff take you time tonight?
Sadly.
Sadly, but yes. Yes, it will.
It's a long day.
Okay. So you're gonna have to start realizing that.
Yeah, yesterday, Chapel included me.
What about this? Let's try another one.
Dogs and cats.
Guys,
I was
focus.
so disappointed
Focus,
with
you
that
can talk about this later, not right now.
Okay.
What about x squared minus 10x plus 25? How do I factor that? X squared minus 10x plus 25. How do I factor that?
Children's book.
X plus
I want to see my homework.
In a minute. X plus 5, what?
I was factoring. Just go straight to factoring.
Okay, so what did you say you're gonna do?
X plus 5, X minus 5.
Perfect. This is a perfect square, that's a perfect square. X plus 5, x minus 5. I don't think that works. Give me a second, let me see
I don't
something.
think it does either.
If you do that, you would get this, x squared minus 25. It's not a difference of squares.
X minus 5 squared.
X minus 5 squared? Yes. It's x minus 5 squared because it is this right here, this pattern right here. U squared minus 2uv plus v squared. So it's x minus 5 squared. Good job, Lindsay. Josh, you had the right thinking going, but if you refoil it to check your answer, it would have canceled out the middle. Okay? So it's a perfect square trinomial. Perfect square trinomial means I have 3 parts and the 2 ends are perfect squares. A difference of squares means I only have 2 parts. Okay? That's how I remember it. What if you have 16x squared plus 24x plus 9? 16x squared plus 24x plus 9. What can you do there? Is this a perfect square? That's what you need to ask yourself first. Is 16 and is x squared perfect squares? Yes. Is 9 a perfect square? Yes. So what do I have going on from over here? Yes, perfect square trinomial. Perfect square trinomial. Now, these are both plus signs, which means that it's going to be a plus sign when I break it down. What is the square root of 16x squared? 4x. So it's 4x plus, what's the square root of 9? 3. 4x plus 3 squared. Do you see how I don't have to do any work if I can recognize that?
Sure.
Okay, I don't have to factor things out and keep going. If you can start to recognize these patterns, have a sheet out with all those patterns written on it in front of you. If you can recognize those patterns, you are going to save yourself some time. What's this one? Try this. X cubed minus 27. X cubed is a cube. Is 27 a cube also? It's a difference of cubes. So the pattern tells me what for difference of cubes? Difference of cubes. Difference of cubes. I should have, what is the cube root of this?
Well,
X.
some people act like a cat.
What is the cube root of this? What is the cube root of 27?
93.
3. Good. 3. Now, this here is this squared, so I get this next number is the cube, this and this multiplied together.
Wait, repeat
Not
that.
not negative.
Wait, repeat
Okay.
that. It's what?
It's whatever the cube root of each of these are multiplied together. So it's x times 3. Okay? So I get 3x. And this is always positive here if this sign is negative. If this was a positive, then that sign's negative. Okay? And then the last number is always the cube root of this squared. So the cube of 27 is 3. 3 squared is 9. And that's how you set up that pattern. Mr. Ray says that one simply has to be memorized or else it's way too difficult to deal with.
Yeah, there's so much to that.
Yes, there is. Because you can mess it up really easy when you go to factor, okay? So those are the types of problems you're going to have tonight. Tomorrow, we will go over trinomials with binomial factoring, things like that, okay? So this is where we're going to stop today.